this video, we're going to talk about a new coordinate system, which is the polar coordinate system. We're used to working in rectangular coordinates where we have an x-axis and a y-axis, and we move in a grid system around the board. Okay. When we're working with a polar coordinate system, in place of the origin, we're going to have a single dot that we call the pole. And instead of having two axes, we're going to have one axis called the polar axis. And the polar axis is a ray. A ray, some books will define it as half a line. I don't like to think about half of something infinite, but that gives you the right picture. If we chop a line in half and have a fixed starting point but no ending point and it goes on in one direction. When we're plotting ordered pairs in the polar coordinate system, instead of an x-coordinate and a y-coordinate, we have an r and a theta. Let me stick a blue dot up here and call it r theta. Now when we are measuring r is like the radius. It's the length of the directed line segment from the pole out to that point. So I'm measuring a straight line from, I'm going to say the equivalent of the origin out to that point. Theta, we measure and talk about theta in the same way we've talked about theta all semester. Positive values if we are moving counterclockwise around, negative if we go clockwise around the circle. But theta is the angle that we make with the x-axis, the polar axis in this case. So when we are looking at a polar coordinate system on graph paper, instead of being a bunch of rectangles, there are a bunch of concentric circles. Okay, everywhere here on this innermost circle is a radius of 1, an r value of 1. And here is r equals 2 and r equals 3, 4, 5, and 6 on this graph. Okay, we can talk in terms of either radians or degrees. When we're giving, our thetas will be given in radians. Okay, but we can think about them in terms of degrees if we still need to. I can't get up here to the top and I couldn't move this down. But straight up is pi over 2 or 90 degrees. We have pi degrees here, 3 pi over 2 straight down. Okay. This place is pi over 4, here's 3 pi over 4, and so on around the circle. I'm going to pause it and label some more of these just so that when I'm pointing at them later that you guys can visualize them a little bit better. Alright, and these guys in between, these are pi over 12. So 1 pi over 12, 2 pi over 12, 3, 4, 5 pi over 12, 7 pi over 12, 11 pi over 12. If you wanted to label all of these, you could go through and do that. So if I want to plot the ordered pair 2, comma, pi over 3, I would come 2 steps away from the origin in the pi over 3 direction, which is right here. So there's 1, 2 steps away from the pole in the direction of pi over 3. Maybe I wanted to go 4 steps in the direction of 5 pi over 4. 5 pi over 4 is here. And if I go 1, 2, 3, 4 steps out, I end up over there. Oop. Did I get it off my map? One thing to keep in mind with polar coordinates, maybe let's do a couple more. Maybe I want to go negative 2. Four pi over 3. So here's the 4 pi over 3 direction. And instead of going 1, 2 in the positive 2 direction, it says let's back up and go 1, 2 in the negative direction. And then look what happens right there. I land on top of my blue dot. Okay, so a good thing or a bad thing with polar coordinates is they're not unique. If I am in a rectangular coordinate system and I say walk to the point 4, 7, there's one place you can walk in and one address I can give for you to land on that point. In polar coordinates, there's an infinite number of addresses for any point that you want to put on your page. If I'm standing right here, 1, 2, 3, 4, I've gone 4 steps and the direction was 0 degrees. Okay. If I want to talk about pi, though, being my angle, then I've gone -4 steps. Or, of course, any multiple of 2 pi added to this. So I could call this 4 2 pi, or 4 26 pi. Okay, or I could say -4 3 pi. Or we could throw negative angles in there as well. -4 pi. Because -pi would wrap us right back around here. -4 would walk backwards instead of forwards. In the exercises, some of the directions will ask you to go to a point and then give it 2 or 3 or 4 other names it designates in there. Okay. But getting comfortable with this, and these are kind of tricky to draw by hand. I think I'm going to ask you to, I think the exercises ask you to put some dots on the page, just a couple. So do the best you can. Make your pi over 3 look like it's between 0 and pi over 2. Always label your points, and I'll know you're pointed in the right direction. But you don't have to get out rulers, okay, and try to break things into even quadrants. In the next video, we're going to talk about going back and forth between rectangular coordinate system and the polar coordinates, and how we can talk about them in either system.